So, what if your own skin could tell you exactly what's happening inside your body in real time? Today we're going to dive into the next generation of wearable tech that goes way, way beyond just tracking your steps.
Look, we're all used to our watches counting steps and calories, maybe even checking our heart rate. But that's just scratching the surface, you know? What if we could go deeper? What if a simple, flexible patch could monitor the actual chemistry of our bodies, giving us a window into our health that's pretty much invisible right now?
And that right there, that's the incredible leap we're talking about, moving from monitoring the physical to really understanding the chemical. So let's see how it actually works.
The first wave of wearables, it was all about physical sensors, accelerometers for movement, optical sensors for heart rate. But the new frontier is all about wearable biosensors. These devices aren't just measuring how you move, they're analyzing the unique chemical markers in your biofluids, like your sweat, tears, and saliva, all without a single needle.
Okay, so how on earth does a patch on your skin actually analyze the chemistry of your sweat? Well, the technology is incredibly elegant. Here's the breakdown.
The secret sauce is right there in the name, a biological recognition element. See, this isn't some simple chemical test. A biosensor uses something biological, like a very specific enzyme or antibody that acts as a hyper-specific detector for just one target molecule.
Think of it like a beautiful two-step dance. First, you've got the bioreceptor. It's like a molecular lock that's been designed to bind with only one specific molecule, the key. So for example, an enzyme called lactate oxidase will only grab onto lactate, ignoring literally everything else. Then, a component called a transducer sees this connection happen, and it converts that chemical event into a tiny electrical signal our electronics can read. It's really that simple. Catch the molecule, send the signal.
Now, this technology isn't just theory in a lab. Nope, researchers are applying it directly to our bodies in some truly remarkable ways.
The skin is the obvious place to start, right? It's our body's largest organ, and it gives us direct access to two really important biofluids, sweat and the interstitial fluid that bathes our cells just below the surface. This makes these flexible, skin-worn patches the leading platform for this new wave of health monitoring.
And our sweat contains a surprising amount of information. I mean, we're talking about metabolites like lactate, which can tell an athlete precisely when they're hitting their limit, or glucose, which could offer a totally non-invasive way to manage diabetes. Even stress hormones like cortisol, or the electrolytes that tell us exactly how to rehydrate. It's a rich, real-time chemical snapshot of our health.
And believe it or not, it gets even more futuristic. Scientists are creating temporary tattoo sensors, these incredibly thin, flexible electronics that you apply just like a kid's tattoo. They stick perfectly to the skin, which means you can get continuous, real-time analysis of something like your lactate levels while you're exercising with no bulky device getting in the way.
And it's not just our skin. Our tears are another fantastic diagnostic fluid. Research shows that glucose levels in our tears actually correlate really well with blood glucose. This has led companies, including Google, to explore smart contact lenses with these tiny embedded sensors, opening the door to a completely painless way for people with diabetes to continuously monitor their sugar levels. Even our mouths are a source of valuable data. Saliva has actually been called the mirror of the human body because it contains so many biomarkers that come from our bloodstream. Researchers have even developed sensors that can be embedded in mouth guards or attached right to a tooth to monitor things like uric acid for managing gout.
So, with all this incredible potential, the obvious question is, where are they? What are the roadblocks keeping this technology in the lab and out of our hands? Because, well, the journey from a brilliant lab concept to a reliable product that's sitting on a shelf is just incredibly difficult, especially when you're talking about our health.
This table tells a really interesting story of both struggle and success. The GlucoWatch, an early attempt, was actually FDA approved, but it got pulled from the market because of skin irritation and the fact that you constantly had to recalibrate it with a blood test. Google's smart contact lens project was also put on hold. But then you see devices like the Freestyle Libre, which show that minimally invasive sensing is possible and can be a huge success. Right now, researchers are tackling three massive challenges. First, accuracy. You have to prove, without a doubt, that a glucose reading from sweat is just as reliable as one from blood. Second is stability. Your body is a pretty complex environment, and over time, proteins and other molecules can literally clog up the sensor. It's a process called biofouling. And third, there's power. How do you run these sophisticated electronics for days or weeks without a clunky, rigid battery?
But despite these huge hurdles, the vision for this technology is so powerful that research and investment are only accelerating. The future of personalized medicine is literally being built as we speak.
I mean, just look at the money. The global market for wearable sensors is projected to hit almost $3 billion by 2025. You don't see that kind of investment unless there's a firm belief that we will solve these challenges.
Because the ultimate goal isn't just to monitor things. It's to create a closed loop, a single integrated system that can sense a problem and then immediately act to fix it.
And this quote explains that goal perfectly. Imagine a patch for a person with diabetes. It doesn't just detect that their glucose is too high, it then uses an array of tiny microneedles to automatically deliver the precise dose of medication needed to bring them back into balance. I mean, that is truly personalized automated medicine.
So in the end, this isn't about tracking just one or two things. It's about building a platform that can monitor a whole panel of biomarkers at once, giving us a continuous, real-time dashboard of our body's chemistry, a true picture of our molecular selves.
Which leaves us with a really fascinating question. With the rise of these sense and act systems, is it possible your next prescription won't be a pill, but a patch, a smart device that monitors and treats you continuously? Thanks for joining this explainer.